Patrol is a powerful, open-source testing framework created by LeanCode that enhances Flutter's testing capabilities by enabling interaction with native platform features directly in Dart. It allows to handle permission dialogues, notifications, web views, device settings, and more. And these are all features which were previously unavailable in standard Flutter tests, so Patrol makes it truly possible to test your whole app, both the Flutter side and the native side, just from within a single test. Hello, welcome to ResoCoder, where you're getting prepared for real app development so that you can be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. This tutorial will take you through writing your first substantial Patrol test, interacting both with the Flutter app itself and also with native permission dialogues and notifications. Before you go ahead and continue with this tutorial, make sure that you have the Patrol CLI installed, and then if you want to follow along exactly with this video tutorial, you can just clone a repository from GitHub, which has this whole app and Patrol native side already set up, so that you can really just clone the repository and follow along. And also, to just follow along through this lesson at your own pace, check out the written tutorial from the link in the video description. Alright, so before we can start writing Patrol tests, or any tests for that matter, we first need to know what we're actually testing. So inside of this tutorial app, we have two screens. The first one you currently see on the emulator right now, and we just want to type in email and password. Email can be any email, but it has to be valid. So test@resocoder.com. Okay. And now the password can be any password. We don't really have any account set up. We are just validating the string input, but it has to be at least 8 characters long. So this will not work. If we type in some more characters, this will work. Okay, sign in. And we're in there in another screen, which will now ask us if we want to allow this application to send us notifications. We, of course, want to allow it. And the only thing we can do from this next screen, the home screen, is to tap on this notification icon, and this will schedule a notification to be displayed in 3 seconds, right? This will work either when we are within the app, so the app stays in the foreground. Okay, Patrol says hello, and when we click on this notification, oops, like this, we have a snack bar at the bottom saying notification was tapped. But also, this will work when we go to the home screen on our device, whether it's Android or iOS. So if we tap this icon, now go to the home screen, so the app is backgrounded, we still get the notification, and when we tap on it, the app is opened, and we again have this snack bar at the bottom, which is displayed. That's really all there is to this app we're going to be testing. And as I was showcasing this to you right now, you've seen some errors that happened when, for example, the password was not long enough. The same would happen if this was not a valid email. So if we remove the .com from the end, it's no longer a valid email, so we get these errors. But the UI tests we're going to write with Patrol should only be testing the happy path of a UI flow. So we only want them to fail if the app suddenly stops the user from doing what the app is for. In this case, that's displaying the notification. But these sort of validation messages, please enter valid email and password must be at least 8 characters long, are not what the app is for. These exist only to allow the user to successfully sign in with a proper email and password. But they are not critical failures in the UI flow necessary to show the notification itself. They're just sort of like side failures. And that's why we're not going to be checking for these in the test we are about to write, but instead we're just going to test the happy path, so the inputs will always be correct and will always get us to this next screen. But if something happens unexpected and for some reason the notification is not displayed at all, which it currently is, but should this not happen, only then the test will fail. So since this app has only a single UI flow, we're also going to have only a single test. The starter project you can get from the link in the video description already contains the integration test folder pre-created for you, and also the apptest.dart file. This is currently completely empty. So let's change that. We want to have a void main function, just like with any other test. And we're going to have a single patrol test. Let's import package patrol. And what are we trying to test here? The description should be really descriptive. So what we're testing is that the user signs in, triggers a notification, and taps on it. This is what we are testing. Now for the callback, it's going to pass us a patrol integration tester. The naming convention in patrol tests is that you name this parameter a $, and this is an async callback, and let's just give it an empty body for now. And one more setup step, which is optional, but nevertheless, you're advised to set it up, is to set the frame policy to be live test widgets, Flutter binding frame policy, fully live. This is so that all of the frames are shown, even those ones which are not pumped by our test code. And while this is optional, without this configured, we would see that our app could stutter and the animations would not be played properly. And because patrol tests are testing the app from the point of view of an actual user running the actual app, when the test is running, the app should be behaving just like it does for a regular human user. All right, now we could start writing the test and line by line test our whole app. So first sign in and then show the notification and so on. And after every line added to this test, right, like this, we could theoretically run the whole test again and again and build the app each and every time we do that. But that is not time efficient because building an Android app or an iOS app takes some time. So while you could rerun the test from scratch every single time by using the command patrol test and then specifying the target to be where this test is located, so that is integration test /apptest.dart. This would become old pretty quickly and it would be time inefficient. So let's instead call patrol develop. This command is a great thing that patrol offers because when you modify the test, you can hot restart your test just like you can hard restart a regular Flutter app, and it will just reset the state of the app, but it will not rebuild it. So that saves you a huge amount of time, and then the test will run with all the new changes included. Let's run this right now. Just make sure that you have an Android emulator or an iOS simulator running before you run this command, because then as you can see, this patrol develop command will automatically select a emulator that's currently running. All right, here we go. So the app is starting and immediately the test has finished, and it didn't even show any UI of the app, which is reasonable because the test is currently not configured even to just simply display the widgets, but at least you can see that everything is running. Let's, in the first step, make sure that something shows up on the screen. So what we're gonna do is, practically speaking, the same thing which happens in main.dart. If you've seen any sort of a Flutter app before, you know that the main function calls runApp and passes the topmost widget in there. We also want to do this from within the test code, but instead of calling runApp, we're going to call the pump widget and settle method. And also, if there are any sort of initializations that need to happen at the start of the app, we also need to call that. And in this case, we need to initialize time zones. This is necessary for the notifications so that they can be delayed by 3 seconds after the button is pressed. That's really an implementation detail. We don't need to worry about why this needs to happen, but we need to run the init app method regardless. So let's copy that, go into app test, run init app, and we can import it from the main.dart file. And then we also need to pump and settle the main app topmost widget. So we can do that by awaiting and now use this $, which is the patrol integration tester, pump widget and settle. And we want to pump and settle the topmost main app widget. And we need to go back into the terminal and hit R to hot restart this whole test. So let's do that. And when we open up the emulator, you will see test is starting. The UI was shown for a brief moment and the test has finished and all the tests passed, but nothing really happened because we really didn't configure the test to perform any actions, but at least we could now see something on the screen. So what do we want to do next? Well, we have those two text fields, one for the email address and another one for the password in there, and we want to type in the email and password. There are multiple ways you can find and then work with, perform any actions on any sort of a widget from within a patrol test. You can find a widget by its type, by text, by key, which is the most recommended way to be finding your widgets. That's to use a key. But for now, let's find these two text form fields by their type. Of course, right now we know that they are text form fields because I've told you that, but you can absolutely go into the sign-in page and see, okay, we have a text form field here and another text form field below. So now that we are sure they are text form fields, we can await. And again, the $sign for the patrol integration tester. And we want to call it directly like this in order to find those text form fields. And for now, let's find them by their type. So text form field. And what do we want to do here with this text form field? There are multiple things we can do, but for now, we would just want to enter text. This text will be test@email.com. And then for the next text form field, let's just copy this line below and we're going to enter some sort of a password that's long enough to be valid. So password is actually exactly 8 characters long, so we can use that. There are ways in which you can avoid inputting sensitive data like email addresses and especially passwords as plain text into your patrol test files. We're not going to cover that in this tutorial, but if you want to learn more, there is a link in the written tutorial to which you can get from the video description. Okay, so we have these two lines, but if you think about it now, it won't work. Why? Well, we have two text form fields on the screen. So how in the world will patrol know that this one is specifying the email field and the second one is specifying the password field? No, that won't happen. What patrol will do in this particular case is they will always access the first text form field from the top of the screen. Let's see if that actually happens. So I'm gonna hot restart the test. And what we're gonna see is that both the email and then the password is rapidly changed just within the single field on the top. So in order for us to actually input this password into the second text form field, we can use the add method, and we can specify that we don't want to access the 0 index, but instead we want to operate with the first index. So that means the second text form field on the screen. And in order for us to also see the screen for more than just half a second after the test actions all are done performing, let's also await future.delayed, and let's wait for duration seconds 1. And now with this change, when we rerun the test, email is input into the first field, password into the second, and also you could see the screen for a bit more time. As you can see, patrol also outputs these nice logs so that you know exactly what's going on. And if some error should happen, they're also going to be quite helpful in helping you figure out what actually went wrong. Let's actually prolong this delay to be 2 seconds. And move it a bit down because this is not really part of the real test code. It's just nice to have, especially for you as you are watching this tutorial. And now to actually get from the sign-in screen to the home screen, we want to tap on the sign-in button. And that button has a text on it saying sign in. So we can use this finder to tap on any widget that contains the sign-in text. Now, when we hot restart the test code again, email is input, password is input, and then the widget with text sign-in is tapped. And as you can see, we are also taken to the next screen, which first asks us to allow Patrol Basics tutorial to send us notifications. Before continuing any further, let's first take a good look at the finders we are using. While finding our widgets by type and also by text would work pretty well in our simple app, if you have anything just a bit more complex, it will become a huge mess and a huge pain to be maintaining your tests with these sort of finders. That's why the recommended approach is to always use keys to find your widgets. The simplest approach to using keys is to first go into your sign-in page, in this case, and define the keys directly on the widgets themselves. So this email text form field in the sign-in page will have key, const, key, and email text field. Now we can copy this, and the password field will have password text field. And also we want to add a key for the button. Its value will be sign-in button. If you have keys specified directly like this, you can access them inside of your test with a symbol syntax, which is supported by Dart. So that means you need to type in a pound or a hash symbol and then the actual key. So the first key for the email text field is email text field. So let's copy that. Then the second field we want to access is the password text field. So let's change that up. Also, now we want to get the first widget that matches the finder, not the second one. So let's remove this @ call. And then the buttons key is sign in button. So let's copy that. When we run the app now, let's see what happens. Actually, you could not see much going on the screen, and nothing really even worked. You can see that we now have an error. Why is that? Well, that's because this native permission dialog is not a part of the Flutter app, which was hard restarted. The native part is not hard restarted. So we need to actually close it manually. That's a good thing to know. So let's now hard restart again. And this time it works properly, which is nice. So let's again manually close this permission dialog. While this approach with keys is much better than with the types and text directly, it's still not perfect, because if a key changes in the sign-in page, for some reason this will be sign-in button V2, and there is also some sign-in button V1 somewhere else, or anything else that changes with these keys, the test keys will not be updated automatically, and you will need to remember yourself to come back to the tests and change them, which is error-prone and time-consuming. This approach is fine for small apps, but for large, complex, production-grade apps, you should have all of your keys specified globally as final variables, and then you will access those same final variables within your test files and also from your actual Flutter app code. So inside of the Pages folder, let's create a new file called integration test keys, and I am just going to paste the code which is available either from the finished project on GitHub or from the written tutorial itself. So this is how it looks like. I already added also the keys for homepage. As you can see, the sign-in page keys contain 3 keys exactly like before: email text field, password text field, sign-in button. But now they are centralized in this class. And the way we are going to access all of these keys is from this keys class instance, which is stored inside of this global final variable. And this keys class contains all of the individual per screen keys classes. All right, so now let's go to our sign-in page and let's change all of the occurrences of directly declaring the keys to instead access the global keys, and then sign-in page in this case, and then the sign-in button. Also for the password text field key, we're going to access the password text field like that. And the email text field will look like this. Now, of course, also from within our app test, instead of specifying the keys with the hash, we instead want to call keys, the global variable, dot sign-in page, and then the email text field. Then the same will happen for the password text field. So let's speed this process up. And then also for the sign-in button. Rerunning the test, so actually hot restarting it, will perform the same actions as before, but now the keys are much better organized. Okay, as you can see, everything worked. Let's again close this permission dialog. Before we continue with testing the home page, let's also go to the home page and pass the newly created keys to the appropriate widgets. Most of the homepage code is implementation details for us at this point, how the notifications are initialized and then shown. But what we are interested in is the icon button on our app bar, because we want to also press that from within the test code. And for that, we need to specify a key, which will be keys from the global variable .homepage and then notification icon. And then we have another key inside of this homepage, which we want to use from within our test. And that's the one for the snack bar, because we actually want to check if the snack bar is shown. So let's specify a key coming from keys, which is not visible because this snack bar is constant. So let's remove that and instead just make the text constant like that. So keys dot homepage and then the success snack bar. Now we can go back to our test code and test our homepage. So as we have already seen multiple times, the first thing that happens when the user arrives on the homepage is that there is the native permission dialog asking the user to allow to show notifications. This is where the Patrol's native automation really shines, because it will allow us to perform actions on the native side of Android or iOS in our case also, just as simply as we have so far performed all of these actions like enter text and tapping on Flutter widgets. To access the native automation, we want to call await, and then on the Patrol integration tester, so the $, we're going to call native. And then there are a bunch of things you can do on the native side. So you can close notifications, deny permission, disable airplane mode, Bluetooth, or double tap somewhere on the native side, like for example, inside of your settings or inside of a web view. But what we want to do is to grant permission when in use. So if there is any sort of a permission dialog, it's going to grant that permission. In our case, that's going to be for the notifications. So now let's save that and hot restart. So the email is filled in, password is filled in, then we go to the next screen and the permission dialog is accepted. The permissions were allowed. So everything worked perfectly. And you can also see that we have these logs. Grant permission when in use. It was waiting for the operation to finish. And then we have this checkbox here, check mark, which means that it has run successfully. So the permission was granted. Now, this granting of a permission has run wonderfully the first time we hot restarted the test, because the permission was, of course, not yet granted. But when we now hot restart the test yet again, we have not changed the code at all. We just want to, again, grant the permission. So let's do that. Hot restart. Let's see what happens. No permission dialog is shown because it was already granted. We already have the permission to show notifications. And so it waits, and then it fails because there is a timeout. Patrol only waits for so long, and then when no native permission dialog is found, it just fails. 404 not found. Selector button to allow permission while using found nothing. There's no permission dialog. If we were to run this on iOS, Patrol actually can automatically reset permissions between runs of the test, even when using hot restart. But on Android, when you are using hot restart, you first want to yourself check if there is any permission dialog actually currently being displayed. So we want to add an if statement, await, and then native is permission dialog visible. And if there is any sort of permission dialog visible, then we want to grant permission when in use. Using if statements, and this is a big disclaimer, using if statements inside of your test code is not usually a good thing. That's because if statements change the flow of the test code. And for the most part, you want your test code to always have the same actions executing. You don't want to perform any logic and decisions based on that logic inside of your test code. For the most part, this is one of the rare instances where having an if statement inside of your test code is a good thing and actually a totally necessary thing to do. But for the most part, if you are thinking about adding an if statement inside of your test code, think twice before adding that, because it could potentially introduce flakiness to your tests. Flakiness simply means that one time the test runs, another time it fails, and you have no idea what just happened because the test is, well, flaky. All right, but with this small change, we can now again hard restart. Here we go. Test is starting. Email and password are filled in. And as you can see, the test finishes successfully. All tests have passed, because when the permission dialog was not visible, that's fine. We're just checking if it is visible. We're not actually waiting anymore, even though it's not visible, to grant the permission. Once we are already inside of the home page and the permission dialog was accepted, the permission was granted, all that's left to do is to actually show and tap on the notification. In order to trigger the notification, we want to tap on the notification icon button in the app bar. So we can do that by, again, awaiting and then keys dot homepage and then the notification icon key. And we simply want to tap on this widget. While we're at that, we also want to test that the notifications and tapping on them works properly also when the app is in the background. So for that, we need to exit the app. We need to go to the home screen. So with Patrol's native automation, this is, again, extremely simple. So we want to call await and then native dot press home. You can also press back and many other things as well, but for now we want to just press home. So with that, we can now hard restart. Everything is filled in. We go to the home screen, the notification button is tapped, and then we navigate home. The test finishes and also the notification is shown, but for now, we are not actually tapping on this notification from the test. So let's change that. Let's just remove this notification manually for now. Okay, so let's now tap on this notification from within our test. To tap on a notification, we first need to open the native notification shade. So that will do the same action as when you manually swipe down from the top like this. In order to do that programmatically from within our Patrol test, we want to call await and then native, and then open notifications. Very simple. And then to actually tap on a notification, we have multiple ways we can do that. So again, native, and then tap on notification. And we can either tap on it by index or by selector. Let's tap on our notification by specifying a selector, because then you have more fine-grained control of which notification you actually tap on, because of course by index, it just taps on the index going from the top of the most recent notifications. So it's not very precise. It's a good method to use, but if you want to be extremely precise, you should really use the selector approach. And now let's specify a selector. So it will be a native selector. And for notifications, as we can see in the documentation for this method, on iOS, only selector text contains is taken into account. And because we want our test to also run properly on iOS, we're going to specify the text contains with an argument like this. And we know that our notifications always have the title patrol says hello. We also know that the notification is delayed by a small time, which is in our case precisely 3 seconds since the pressing of the button inside of our Flutter app. So in order that we do not try to tap on this notification before it's actually shown, we also want to specify another argument here, which is the timeout duration. You can see that it's nullable, and the documentation says that if timeout is not specified, it utilizes the default find timeout duration from the whole patrol configuration. But just to be safe, let's specify it manually here. So that will be timeout and then const duration, and let's say seconds 5. So that should be plenty enough to wait for the 3-second delay for our notification to be displayed. And once we tap on the notification, we are of course going to be taken back into our app. And we know that a snack bar should be shown at the bottom of the screen if everything works successfully. So the last step in our test code will be to find our success snack bar. So we're no longer operating with anything native. We are back in our Flutter app. So we can just use the patrol integration tester and then keys, homepage, and the success snack bar. And we want to wait until it is visible. And let's actually also await this. Let me also remove this future.delayed from the bottom because we don't no longer need this. We actually never really needed that, but it's nice to have because otherwise it just runs way too quickly for us to see anything at the end of the test. And yeah, let's hard restart the test yet again. And let's see what it does. Actually, as you can see, it currently does things, but you cannot really see them. So if that happens to you, that's because the test can actually run even when the app is backgrounded. You cannot do that when you are a real human user of the app, but the runner of the test on Android can do that. So if that happens to you, you want to really just open up the test app like this. And now hard restart again. And now we are actually going to be able to see everything. So, yep, we are now going to click on the button. We are taken to the home screen. We wait for 5 seconds. Notification is displayed. Now we tap on it. And then we could see for a brief moment that at the bottom the snack bar was displayed. So everything has run successfully. We can see all the logs that everything happened as it should. And all tests passed. So that's great. Actually, I now see that we have a warning because this material import is not used. So let's just remove this. And now that we have successfully tested this on Android with our Android emulator, let's now quit this test. So I'm going to hit Control-C, and I am now going to launch an iOS simulator like that. And we could just run the one-off test, but let's again call patrol develop. But because the Android emulator is now the first on the list of running emulators or simulators, we also need to specify the device to run on. So there will be the -D, and then I think it's called iPhone 16 Pro. So we need to call it exactly like that. So iPhone 16 Pro. All right, that has worked. And we're now building the app for iOS. Right, and as we can see, we're now running. We're already in the home screen. And notification was tapped and the test finished. I could not even see the success snack bar myself, to be honest, but the test has checked that it's actually there. And just like that, we have now tested the whole flow of the app with Patrol, both on Android and on iOS. And with this test in place, if anything breaks in our happy path, the happy UI flow that our user can take, we're gonna be notified about that. To get through this tutorial at your own pace once again, and also to get all of the code which we have written in this tutorial, check out the written tutorial available from the link in the description. And if you do not want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. So, if this video helped you with writing your first Patrol test and also understanding how it all works with the Patrol native automation, give this video a like, leave a comment if you have anything to say, and see you in the next video.